Bryanna Sherbo is an aquatic science technician working for Fisheries and Oceans Canada in the Arctic and Aquatic Research Division. She's currently working on using satellite imagery for detecting marine mammals, such as narwhal, beluga, and walrus in the Canadian Arctic. The goal of this project is to use imagery for distribution and abundance estimates. Previously, she obtained her Bachelor of Science from Acadia University and her Master of Science from the University of Manitoba. Bryanna, I give you this stage.
Can you hear me and can you see my screen?
Yes, we hear you well.
Okay, great. So thank you for the introduction, Romina. I'm going to talk about satellite imagery for detecting marine mammals in the Arctic. And as mentioned, my name is Bryanna Sherbo, and I'm an aquatic technician for Fisheries and Oceans Canada. I'm based out of the Freshwater Institute in Winnipeg, Manitoba. Throughout this presentation, I'm going to give a little bit of an introduction to satellite imagery, as this is the first presentation in this session. And then I'm going to talk about different marine mammal detection methods, which include manually reading images, specifically for beluga and narwhal, a crowdsourced project that we conducted in 2020, and some preliminary results from that, as well as a ground truthing study to determine the depths of whales that we can see from satellite. And then I'll move into some auto detection methods for detecting beluga and walrus and give a little bit of a conclusion. So for a background into satellite imagery for mammal detection was first suggested by Ron Abley in 2021, and this was using 1 meter resolution imagery. Since then, the field has vastly changed, and now there are commercially available satellite imagery for under 40 centimeters, and that can be used for detecting marine mammals in remote locations. There are certain factors that need to be considered when using satellite imagery for distribution and abundance of marine mammals, including imagery acquisition, environmental variables like cloud, water clarity, wave action, sun glare. This background image is supposed to be of Walrus Island, and during the collection period, there were no cloud-free images. And so that is kind of a downfall when using satellite imagery is cloud, especially in the Arctic when the open water season is characterized by persistent fog and cloud cover. This study focuses on using satellite imagery to detect narwhal, beluga, and walrus. And I just want to mention that the use of satellite imagery for us started or became more widely used in 2020 with the pandemic highly restricting travel. Moving into manually reading imagery, I thought I would just start with some satellite imagery to go through for people who haven't seen satellite imagery with whales before. And so as I go through the next few slides, think about how many whales you would count in each slide. This is an example of a panchromatic image. The images that I'm going to show in this presentation are from the company Maxar Technologies from their Worldview 2 and Worldview 3 satellites. This is an example of aggregated whales in both panchromatic and pan-sharpened imagery. Pan-sharpened imagery is where panchromatic and multispectral imagery are combined for higher spatial and spectral resolutions. This is a sharpened multispectral image. And now going back through the slides we just looked at, and here there are five red triangles for georeferenced feature points of confident beluga whales. even though these circular dots do look like circular dots, we believe they are beluga because of the formation that they are swimming in here. And this photo was taken in Clearwater Bay off of Baffin Island. In this next photo, we have an aggregated whale grouping of 14 beluga whales, and this image was taken in Creswell Bay off of Somerset Island. The features for manual reading are labeled as confident whales and as less confident whales, and so for the purposes of another observer rechecking the imagery, that they will go back and check the uncertain as well as certain feature points that were documented. This image I just threw in there for fun. There's no whales in here. There are some white dots from pixels and maybe waves. Moving in to the crowd counting methodology in multispectral and panchromatic satellite imagery covering a total area of 14,000 kilometers squared was collected during the low to no ice season of July to September in 2020. From areas that beluga were previously observed, I have a map here. I'm not going to go through all the locations, but this dot over here is Creswell Bay, which I mentioned in a previous photo, and this is Clearwater Fjord, which was also mentioned in a previous photo. These areas were determined based on prior knowledge of summer distribution to determine the specific areas of interest for belugas. The satellite images were divided into a 250-meter grid for a total of 230,000 tiles. These image tiles were then pan-sharpened and stripped of all geographic identifiers, and then an online imagery reading campaign was conducted where paid crowd counters who did not have any knowledge of previously identified features, they documented whale features as georeference points. So each tile was read and tagged with features of interest, and bounding boxes were drawn around these features of interest. Following, the crowd counters voted on the likelihood of features as whales to obtain a confidence score for each feature. In this image, the red dots are confident whales and these yellow dots are uncertain features to be re-examined. And to ensure the accuracy of this, people experienced reading satellite imagery reread 5% of all the imagery we received. So some preliminary results from this study. These are just the confident whale points. The confident whale points were clustered to prevent multiple points from being counted as multiple whales if points were not precise across crowd counters. The clusters were only applied across crowd counters. If 3 whales were identified by one crowd counter, it would result in 3 whale points. And this cluster analysis was done as 0.5 meters and 3 meters. And the whales detected for these estuaries range from 8,000 to 11,000. And I will just mention the previous aerial survey that was done on these areas for beluga was in 1996, and they determined that there were about 21,000 whales. So this is a little bit lower, but this was also more of a proof of methodology than a specific abundance estimate. Moving into our ground truthing study, whale detection from satellite imagery comes with uncertainty regarding the depth of observed individuals. And as such, we conducted a ground truthing study at the International Institute for Sustainable Development's experimental lakes area, where we deployed whales in a clear and murky lake. This, you can see the whale here is the inanimate whales that we used and deployed in freshwater lakes. I will mention that this study was previously attempted to be conducted in the ocean. However, with tides and storms and the amount of time that this satellite company needs to task a certain area, it was unsuccessful. And so this is why we moved into freshwater lakes that don't have quite the same issues. Results from this study were that whales were detected at 2 meters deep in the clear lake and 1 meter deep in the murky lake. And this is a panchromatic image and multispectral image of the clear lake. And in the clear lake, we also deployed a whale at 4 meters, which is the Secchi depth. But it wouldn't be detected as a whale. So these are the two whales. And this is pretty far zoomed out. When you zoom in, they look a little more whale-like. So moving into the auto detection methods, right now, our research scientist, John Akosa, is focusing on the auto detection methods. This image here kind of just shows how it's a little bit complicated with the images that we're working on. And before running the algorithms that he's working on right now, he does a land mask as well as a cloud mask to kind of help the program out a little bit. So far, it's definitely a work in progress, and there are some limitations that John has found, especially when it comes to groups of whales. Here, the method detected these 2 whales as one, and with whales below the surface, here he has detected, the method, has detected 2 whales where there is 1/3 whale below the surface that is missing. And as well, another limitation is multi-segments being detected for just 1 whale. So here there would be 4 whales detected when there is really just 2 in this. So this is a work in progress that is next step for us. Now I'm going to move into the walrus auto detection. This image was taken of Walrus Island, south of Southampton Island in the northern part of Hudson Bay. This is a 30 centimeter resolution image taken by Maxar's Worldview 3 satellite. So this is showing zoomed in sections of the pan sharpened image to groups of hauled out walruses. And so you can see that walrus are visible in the image with the distinct coloration from their background. This was done using 4 color bands: red, blue, green, and near infrared in the pan sharpened image. This is that same image further zoomed in. And as you can see, this demonstrates that the 30 centimeter resolution is insufficient to clearly identify and count individual whales manually. Also, I just want to note the walrus in the water have quite a different spectral signature than the walrus hauled out on the land here. So in order to use this data, we were able to estimate the walrus per area using different classification methods, and then apply that area, the density for that area across the entire island. And this was done by comparing the satellite imagery data to data from aerial surveys that was done on this exact same island and had walrus hauled out in these 4 different polygon areas. And then that was the density estimate that was used, translated for the rest of the island. Shown here, this is the polygon locations indicate the areas where the walrus density was determined. The density estimates per zone are kind of shown as these red circles. And they were applied for the total area of the island, resulting in estimates of walrus ranging from 2,000 to 8,000 walrus for this island. And this past summer, we conducted an aerial survey of the higher Arctic walrus population and got satellite imagery data from the exact same day as aerial photographs were taken. And so we will be revisiting this methodology with the new data we've since just collected in August. And I will mention this study was done by Matthews et al., colleague of mine at Fisheries and Oceans Canada. This is just showing the whole island. And in conclusion, their future higher resolution satellites are coming out. The Maxar Legion series will be sent into orbit by 2025 and will have the capability of revisiting sites up to 15 times a day, whereas right now there is only capability of going back to a site once a day as it orbits around the longitudinal axis. And our next steps are we're working on analyzing winter imagery right now. It's pretty difficult. This is a winter image in the background here, and there's a lot of ice that looks like whales or whales that look like ice. This is still very much under development right now. And our next steps are to finalize the auto detection methods and publish some of our data. And as mentioned previously, we're going to work on comparing our walrus satellite imagery just collected to the aerial survey imagery that was also just collected. I just want to thank everyone for listening and ask if anyone has any questions.
Thank you, Bryanna. That was a great talk. Thank you. We have one question in the chat, and this is about the cost of obtaining these high-resolution satellite images.
They are very expensive. They are, if I remember this correctly, it's about, I might have to check my notes. They're extremely expensive. Like I want to say it's $60 per like square kilometer. I'm not sure if that makes sense. Maybe don't quote me on that. I will get back to you.
Sounds good. Does the government have like a special plan with these, or is this project financed?
This is, so we got funding through this Nature Legacy funding for a 2-year project to kind of conduct this research to see if it was feasible and then kind of go from there.
Sounds good. There's a question of where is Walrus Island in Nunavut?
It's located south of Southampton Island in the northern part of Hudson Bay.
Thank you. Do you have a comment on the ability to detect other species through satellite images like bowhead whales or bearded or ringed seals?
Bowhead whale work is definitely being done right now. The satellite imagery, at least that I look at, doesn't include areas that bowhead are typically located in, but it is in the works with another colleague of mine. The bowhead are quite easy to see from the satellite image because they are so big, whereas in comparison to the beluga and the narwhal, they're quite a bit smaller. I am not familiar with any work right now that's being done on bearded seal though.
Okay.
Or ring seals.
Right. Thank you. Let's continue the discussion in the breakout rooms, and we'll go on with